Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 4, Section 1, Congruent. So first we start out with the definition of congruent polygons. Congruent polygons have congruent corresponding parts. In other words, all their matching sides and all their matching angles are congruent. Okay. Note, when you name congruent polygons, always list corresponding vertices in the same order. So they give me an example here and they give me a picture, but I don't actually need the picture to do the corresponding parts if we realize that all the corresponding vertices must be in the same order. So when they tell me that triangle TJD is congruent to triangle JCF, that means that T has to correspond with R, J has to correspond with C, and D has to correspond with F. So if I want to list all the angles that correspond, I would say that angle T and angle R, angle J, and angle C, and angle D, and angle F. And if I want to do all the corresponding sides, then I just have to make sure that when I list the points for the sides that I list them in the same order. So I could say that TJ and RC and also JD and CF, and the last ones would be TD and RF. And when I did that, I didn't even really look at the picture off to the side to decide what were the corresponding parts. Okay. Decide whether triangles are congruent, justify your answer. Now, we are going to use congruent polygons today, which means we have to show that all the angles that are corresponding are congruent and all the sides that correspond are congruent. In the next two sections, we're going to learn easier ways that we can prove triangles are congruent. So if I take a look, I see that we have angle E and angle A, and they're labeled as congruent. So angle E is congruent to angle A. Check. I also have that B and D are right angles, so angle B is congruent to angle D. And if I had to use that in a proof, I'd call it, right angle theorem. All right angles are congruent. And the last one I have are vertical angles. So this one I do need three letters because there's multiple. I can't just call this angle C because there's multiple angle C's. So angle BCA is congruent to angle DCE. Check. And then if I take a look at my sides, I've got BC is congruent to CD. Check. I have AB and ED. And the last ones I have are labeled as congruent, AC and CE. So check, I have three sets of corresponding sides congruent, three sets of corresponding angles congruent, and so yes, they are. If they asked me to write a statement of congruence, what I could say was triangle. Now, once I decide which way I'm going to label one of the triangles, I have to make sure the other one I label correspondingly. So how about I call this ABC is congruent to A lines up with E, so it'd be triangle EDC. Okay? And that would be a statement of congruence. So, given triangle, we're given all these corresponding parts that are congruent, prove the triangles are congruent. So this proof I am going to do in class, but I want you to take a look at it and think about what we have to do. Because we're not allowed to move ahead in the book and take a look at what we're not allowed to use sections 2 and 3. To do this proof, what we have to do is show all the corresponding angles are congruent, all the corresponding sides are congruent, and then we can say the triangles are congruent by definition of congruent polygons. I have one more thing, and I've added this at the bottom. This is called the third angle theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Okay. So just put this one in your notes. You are allowed to use it. It's called the third angle theorem, and I will prove this one for you also. Okay? That's it for today's video. Thank you for watching. Have a great day.